Hey everyone, Mr. Kaczynski here, working on the last skill in IXL's 8th grade math section P. P.16 is congruent triangles. And being able to identify congruent triangles is important because once we identify two triangles are congruent, we can use proportions to find missing sides. And that'll help us solve real-world problems. So, first of all, to determine two triangles are congruent, we must identify a minimum of 3 pairs of congruent corresponding sides and angles between the two triangles. So here's the 3 rules that we're going to work with today. Side, side, side. If two triangles have 3 pairs of congruent corresponding sides, we can determine that those triangles themselves are congruent. Side, angle, side. If they have 2 pairs of corresponding sides that are congruent and an angle between those 2 sides that are congruent, we can identify that the 2 triangles are congruent. And then angle, side, angle. Again, really if they have 2 angles that are congruent, they have all 3 because all 3 angles in a triangle have to add up to 180 anyway. And then if they have 1 side that's in between those 2 angles that's congruent, then we can identify them as congruent. But just because you have 3 pairs of corresponding sides or angles that are congruent does not guarantee that the 2 triangles are congruent. These patterns don't prove congruency. Angle, angle, angle. Just because 2 triangles have the same 3 angles doesn't mean that they are congruent triangles. It means they're similar triangles. And similar is big, but not congruent. And then lastly, there's SSA. Side, side, angle. And yes, I put that in that order on purpose because as I tell my students, there's no swearing in math class. So I was very careful to put side, side, angle and not some other order. All right, so we can't have side, side, angle. The angle actually has to be between the 2 pairs of congruent sides. I'm going to show you some examples of these, and I think you'll blaze through this skill on IXL. All right, which rule explains why these 2 triangles are congruent? All right, well, we've got this side, which is congruent to this side. We've got this side that's congruent to this side. And we have this side that's congruent to this side. That's what those marks mean. All right, so that is side, 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 side. We can determine that these 2 triangles are congruent by the side, side, side rule. All right, what about these 2? If they're congruent, how do we know? Well, we've got this side that's congruent to this side. We have this side that's congruent to this side. And in between them, we have this angle that's congruent to this angle. So we can determine they are congruent by side, angle, side. Side, angle, side. Okay, what about these 2 pairs? All right, we have this angle, which is congruent to this angle. We have this angle that's congruent to this angle. And in between them, we have this side that's congruent to this side. So that is angle, side, angle. Angle, side, angle. Which is a rule that will prove congruency between 2 triangles. So there's there's examples of all 3 rules that we have. All right. Can we conclude that these triangles are congruent? Well, we have to have at least 3 pairs of congruent corresponding sides. Here we have 1, 2, and that's not going to get it done. So no, all right, we cannot determine that these 2 triangles are congruent. We have to have at least 3 pairs of congruent corresponding sides or angles. Well, here we have 3. We have an angle to an angle. We have another angle to this angle. And of course we have this angle to this angle. So 3 pairs of corresponding angles that are congruent to each other. But angle, angle, angle is not one of our options. So in this case, these triangles cannot be proven congruent. Angle, angle, angle is not a rule that will prove congruency. It'll prove similarity. So they could be similar to each other, as in one could be larger than the other in the same shape though. All right, we have three pairs here. Are these congruent to each other? Well, we've got this side congruent to this side. We have this side congruent to this side. However, this angle, which are congruent to each other, are not in between the sides. So this is an SSA situation. We want an SAS. See, the A has to be between the two sides. So that is not the case. We would need these two angles right here, which we don't know to be the case. All right, so we cannot prove that these triangles are congruent. Just a couple more. Are these triangles congruent? Well, I have, what do I have here? I have side, I'm sorry, I have angle, side, angle. Angle, side, angle. So yes, these can be proven congruent by the angle, side, angle rule. Can these two triangles be proven congruent? Side, side, side. Is that one of our rules? Yes, it is. Side, side, side is a rule that will prove congruence. And one more time here are these. We have side, side, angle. Side, side, angle, and again, I'm being careful of my order, is not a thing. So these two triangles cannot be proven congruent. I think you'll probably make some mistakes here and there as you're going through, but you'll probably get to a SMART score of 100 pretty quick after watching this. So good luck to you, and let me know how it goes.